In this video, we're going to take a look at the unintended solutions to the January challenge, which was created by Kevin Mizu. And the reason I say unintended is because we didn't get any intended solutions during the week that we ran the challenge, but we did get 37 unintended solutions. So Kevin's actually running a patched version of the challenge at the moment that doesn't have those unintended solutions in it. So maybe we'll come back after and make another video on how to do the intended solution. If not, we're also making a blog post, so you can check the description and go and check the write-up for that as well. I'm not going to read through all of this challenge information on the page. One thing I will say is we are now giving a €100 swag voucher to the first blood on each challenge, so we'll update the rules for next time as well. And the description for this one says that we need to find a way to execute arbitrary JavaScript on the iframed page, and then we can win some Intigriti swag. Alright, and if we scroll down the page, we can see that we have the challenge here. You can actually download the source code as well. I like to open the challenge in a separate page, so I'm going to open that up. Okay, we've got an input field here, which is asking for our name, so we could just play around with this and try and work out what the basic functionality is, but we have got the source code available for download, so I'm actually going to jump straight into that. So I've opened this up in VS Code, and I've gone straight to app.js, which luckily only has like 50 lines of code in it, so not too much for us to analyze. The first thing we might want to do is have a look and see if there's likely to be a vulnerability with any of these libraries. So we've got DOM Purify, we've got JS DOM. Let's go to our package.json and see what versions are in use, and we could just go and start Googling, see if there's any vulnerabilities here. But notice that it says version 3.19 or above, and it's doing that for each one of these. So if there was a vulnerability, let's say with 23.0.1 JS DOM, then the next time a new version of JS DOM comes out, this challenge is going to break because it's going to install the newer patched version. So if this was vulnerable, you would expect to see a fixed version here. So returning to app.js here, we've got two routes. One is a get route to the index, and you can see here that if a name isn't provided as a query parameter, it will render index, but if there is a name, it will try to render search, and it's actually using the DOM Purify sanitize function on the name query parameter, and then it's not using it on the search parameter for some reason. So maybe we want to go and have a look and see what this option is that's being provided to DOM Purify. So I've moved over to the GitHub for DOM Purify, and there is an example here which has the sanitize DOM option set to false, and it says this will disable DOM clobbering protection on the output, and by default it's on, and we should handle with care because there are minor XSS risks here. So it looks like the author has specifically set an option which will enable DOM clobbering. Okay, so we'll take a note of that and we'll move back to our second endpoint, which was the search endpoint, and this is a post request, and it takes a queue parameter, which then becomes name, and refers to a repo name. This function is essentially going to search through a list of repos looking for a name that matches, and if it finds one, it'll return as a JSON object. And we can go to the repos.json file and have a look at some of these. Actually, there is 30 JSON objects in here, each representing a repository, and there's around 3,000 lines of code in total. So there's no point reading through all of this. Well, I say code, it's actually data, but there's no point reading through all of this as long as we know what kind of information we're expecting to see in here. And we can have a look at some of the other files then. We've got an index.ejs, which has very little code in it. Probably don't need to worry about it too much. It's taking that name parameter, and then we've got a header, and the last file, which is probably of interest to us, is the search.ejs file. And why is this likely to be of interest? Well, this is where the majority of our search functionality is, so where there's functionality, there's likely to be bugs. And what do we have here? We've got jQuery is being imported. We've also got axios, so if we're not too sure what this is, maybe we can go and have a quick look at the documentation. And we'll find that it can make XML HTTP requests from the browser, it can make HTTP requests from Node.js, it supports a promise API, can intercept requests and responses, transform request and response data, cancel requests, automatic transforms for JSON data, automatic data object serialization, and client-side support for protecting XSRF. So let's try and break down some of the functionality here. We've got a window onload function, which is going to execute when the window loads. And if the URL contains a search parameter, it'll be extracted, and then the search function is triggered automatically. And then an event handler is attached to the search form to monitor for future searches. So what happens when the search function executes? Well, we can see here that it's going to make a post request to the search endpoint using the Axios library. Then if the search query matches, the relevant repository data will be returned in JSON format. The image.avatar source will be set to the repo.owner.avatar URL. The description text will be set to the repo description. And if the repo homepage starts with HTTPS, the homepage source will be set to the repo homepage, and hidden will be set to false. Now, we had looked to see if there was any vulnerabilities with the package.json, but we've also got two libraries imported here. We can see the jQuery version, so we go and have a look for vulnerabilities in that, but there's no mention of the Axios version, and it's minified, so as you can see, this isn't going to be very easy for us to find it. We can try and search for version here, but it's kind of obfuscated. So if we want to try and find out if there's any vulnerabilities, we need to find out the version first. There are some different ways to do this, but the approach that I chose was to set up a breakpoint. Let us first supply a name. So I'm going to put in here cat, and we want to make sure that we can actually select the axios.min. There we go. Okay. So we can actually format it a little bit nicer here, but I want to look for that version. It's not that one, that's the HTTP code, but it looks like this might be interesting. So I'm going to set a breakpoint at this line here, 2277, and then let us refresh the page. We do that, it's hit the breakpoint, and we want to try and find out what these values are. So this version is undefined, but it's going to be set to ZE, and ZE is 1.6.2. So there we go, we've got the version of the Axios library. Alright, so moving over to the Axios GitHub, we want to go and have a look at the release notes and see what actually happened since 1.6.2. So there was 1.6.3, which had a denial of service. That's not likely to be of interest to us. We want to get XSS. And then there's 1.6.4, which fixed the form.to.json prototype pollution vulnerability and fixed the security vulnerability in follow redirects. So we can basically start having a look at some of these and try and work out, are they going to be of interest to us? This one might be, because let's actually go back to our code. So we know that Axios is making a post request and it's taking in a search form, and then it's going to return a JSON object. So maybe FormDataToJSON might be a function that's used here, and there seems to be a recent vulnerability. So back to the GitHub issue here, we can go and have a look to see if there's any example payloads. We can see there is a form data append where they've added some prototype pollution. And we could also go and have a look to see how they fixed this. Maybe some of the code that they added will give us a hint. But for now, let's just take a note of it. We can come back to that later. We want to try and formulate an attack plan. And we'll start off by going through some of the functionality here. So we've already tried providing a name, and you can see the name came back as cat. It's already in bold. I normally try to check to see if we can put this in bold, but we can't here. So I'm actually going to change it to U. So I'm going to add the U tags here to see if it's going to underline it, because we did see that this might have DOM clobbering. And whenever we do that, we actually see, yes, we've got HTML injection in the name parameter. So that's good to know. It's also now asking us what repo we're looking for. So let's just try and type something in here. I'm going to put in test, and it comes back with an alert to say that wasn't found. So we could go and have a look at the repos in that repos.json file and find one. There's actually one called Facebook. So I'm going to do Facebook. And there we go. It actually loads up an iframe with some of the information. It loads an image showing the Meta logo. And actually, we can also use different characters here. So I can do FB, will also bring back the Facebook. Okay, so we've got HTML injection, but what about the DOM clobbering risk that was mentioned in the DOM Purify documentation? Well, according to Portswigger, DOM clobbering is a technique which lets you inject HTML into a page to manipulate the document object model, or the DOM, and ultimately change behavior of JavaScript on the page. So let's return to our search.ejs file. I basically threw this code into ChatGPT and asked it for a quick breakdown, and the Axios post request is making a post request, obviously, with the Axios library to the search endpoint. After that, it takes the jQuery selector, so it's basically selecting a element with the ID search, and it's getting the first element. So this is usually done to serialize the form data for submission, and it's interesting that it's taking the first element, considering there is only one search field on the page. And then the headers are set to application.json because the form data seems to be being converted into JSON and then returned. Alright, so the jQuery selector is taking the first search element from the screen, and that sounds like a nice target for clobbering. If we can inject our own search form before the existing form on the page, it'll be processed in the Axios request instead of the intended one. We've got a very simple one here. We've got a form ID is search, and then we've got an input called cat, and the value is the best. And notice then that it says, hey, is the best. So we've got two fields now. I'm going to hit F12 and bring up our console. And then we can also verify this here. So let's do that jQuery selector. It was taking the search element, and then it was getting the first one. And there we go. It's come back with this form ID search. and the input is cat with the value is the best. Now, what can we do with our clobbered search form? Well, we noted earlier that there's a form.JSON client-side prototype pollution vulnerability in the Axios library, so let's investigate that. First, what is prototype pollution? Portswigger has a lot of labs on this and some great theory behind it, so I'd recommend checking those out. But in short, prototype pollution is a vulnerability that occurs when you merge an object with a user-controlled JSON object. It can also occur as a result of object generated from query or hash parameters when the merge operation does not sanitize the keys. And for successful exploitation of prototype pollution, we need the following key components. The first is a prototype pollution source, which is any input that enables you to poison prototype objects with arbitrary properties. The second is a sink, which is a JavaScript function or a DOM element that enables arbitrary code execution. And finally, an exploitable gadget, which is any property that is passed into a sink without proper filtering or sanitization. So if we go back to the Axios issue and actually have a look at the fix, it was actually a very simple fix. So it was one line that was added and it just says if the name is equal to __proto___, return true. And then they added a new test case as well, which will basically check to make sure it's not vulnerable to prototype pollution. We could also open up the full file if we want to see exactly what is happening in this FormDataToJSON. And if we scroll down, let's see where our fix was added. It was right here, line 53. So let's test this out with a very simple, benign payload. I'm going to paste in here a form. So again, we're just clobbering the search form. But this time, instead of just putting in any random input field, we're now setting a prototype, which is called cat, and the value is the best. And I'm going to hit enter and wait for the page to load. Let's go and have a look at our developer tools again. And if we go into the console, what I want to see here is if we now type object.prototype, and you can already see it, but let's just do it anyway. So object.prototype.cat is now set to is the best. And if we do object.cat, it's also is the best, or just simply cat. And the reason being, we have polluted the prototype with this cat object so that every other object will now inherit it. Of course, this is a very benign payload and isn't much use, so we want to go and try and find one of those dangerous gadgets that was mentioned on Portswigger. We could go and check the BlackFan Git repo, which has a list of gadgets, and specifically a lot that are for jQuery. There was one of these was actually used in, I think, the June 2023 Intigriti challenge. So you could go and start trying to see if some of these will work, but you won't actually have any luck with them. Similarly, you could have a look to see if there are any known gadgets in the Axios library that we could use, but you'll also run into the same issue. Okay, I think everything's coming together now. Let's have a look at some of these unintended solutions. I just want to mention first of all that if this section of code was removed, the unintended solutions wouldn't be possible. So the patched version of the challenge, that's exactly what was changed. It just removes this part of the code, which means we want to try and focus on what vulnerabilities might be here. Now, the thing is, in order to reach this vulnerable code, we've got to meet a couple of conditions. The first one is this condition here. It says if the repo owner isn't set, it's going to return, and then none of this code will be executed. The second condition is right here. So if the repo.homepage isn't set, and it doesn't start with HTTPS, then this section of code won't be executed. So we need to meet both of these conditions before we can actually get to this. So back to the challenge page, let me open up the debugger and let's go and have a look at our code. Make sure this is formatted properly, and I'm just going to set up a breakpoint around here. It's not really needed, just if you want to actually see what's happening. And I'll refresh the page, so it's sending the same payload. And you can see as it gets down here then, the repo.owner is undefined. So it's going to say not found, and then it's going to return, and it's not going to execute any more of that code, which is okay. What we want to do then is try and pollute this. So we know we've got prototype pollution now. Let's change this to something useful. And let's say that the owner is cat. We'll hit enter, and I think that might have removed our breakpoint. So let's go back and add it. Set the breakpoint here. We will reload. And now, if we have a look at the owner, you can see the owner is cat, which means it is going to meet that condition and it will get to the next part of the code. But then, as we step through, we'll get to this repo.homepage, which is undefined, so it's not going to execute this code here. So what do you think we're going to do? The same thing that we just did. So we could just add another parameter here. We obviously want to make sure it is beginning with HTTPS. I'm going to change this to homepage, and then I'll put in something here. Let's do HTTPS crypto.com. repo.cat, which is a domain I really wish I owned. And we'll try to load that. It's going to remove our breakpoint again. Let's just set up the breakpoint and verify this. Refresh the page. And now you can see that the repo.homepage is set to crypto.cat, which means whenever we now step over this, we get to the jQuery attribute. And you can see what's going to happen here then. The source of homepage is going to be set to repo.homepage. Let me now remove this breakpoint and then just hit continue. And you'll see here then that it says Firefox cannot open this page because it's trying to open our iframe, which was that crypto.cat. So if we could simply set our homepage to be JavaScript alerts and then in brackets document.domain, that would be enough to trigger our alert. But unfortunately, this is what's preventing us. It needs to start with HTTPS, and this is the iframe that we would love to be able to just set to a JavaScript alert as the source. Another thing we may notice here since doing this, that we now get an exception in the console. So you can see here it says uncore in promise, type, error, and it cannot use in operator to search for set in cat. And you can see that was the proto owner. And this is actually an error from inside jQuery from the atra function, which was now being called because we met both of those two conditions. So a lot of players actually studied this to understand what the underlying cause was, and you can make that process a lot easier by using source maps, which will basically negate the need to debug the minified JavaScript code. And there are some great examples in the community write-ups which were done this month. We got 7 of them, so I'd recommend going and checking those out. I'm not going to go through a lot of the stuff that was covered in some of those. But the TLDR is that the loop inside the atra function will crash when it's trying to process strings, and that includes our owner and the homepage. In fact, the homepage must be a string because we know that we need to meet that condition which says that it should begin with HTTPS, and that is testing a string. So even if it was possible to change the owner to something that isn't a string, we can't easily get around the homepage issue. But we can verify this anyway. One way we can do this is by changing the owner to an array. So just put in some square brackets here, load the page, and notice that now we get the error, but it's on the homepage, not on the owner. So we can do the same thing with the homepage, add our square brackets, and this time we get a new error which says repo.homepage.startswith is not a function because it's trying to check that the string starts with HTTPS and instead it is getting an array. Actually, there's another way to get around this error as well. So if there are any uppercase characters in the attribute name, it will be converted to lowercase. So there's a toLowercase function which will change the execution flow in such a way that the in array call inside atra won't actually be used. So as an example, let's change this. Let's remove those square brackets. Let's change owner to have a capital O, and let's change homepage to have a capital, and we'll reload the page. And notice that we don't get those errors now about the jQuery exception. So out of the 37 submissions that we received, 24 of them polluted the owner and the homepage like we just saw, and soon we'll have a look at how the 13 solutions that didn't use the owner and homepage were able to get around that, still without using the intended solution. However, for the solutions that did set the owner and the homepage, it's at this point that they begin to diverge. So let's have a look at how we can trigger the XSS in some different ways. If we go over to Hattrix, we'll see there's some documentation about how we can get XSS in an iframe, and it suggests using the source or srcdoc. Now, the source attribute is already being assigned, the repo homepage, which must begin with HTTPS as we've already been over. So let's try the srcdoc. So here's an example of the form that I'm going to use. So we're injecting the search form and we've got an input, which is our srcdoc. So we're polluting the prototype for that with the XSS payload. And then we also need to pollute the owner and the homepage because we want to meet those conditions. Now, need to make sure this is URL encoded. I'm actually just going to paste this in and we'll see that we don't get an alert, but we're also getting this error saying it cannot use inside of that script. So why don't we just try the technique that we just talked about? So perhaps we can use an array for the srcdoc. And if we do that, we get our alert with document.domain. Let's try that again and do it with the uppercase. I'm going to do srcdoc, and we get our alert again. So by using those two tricks, we were able to actually pollute the prototype and then trigger XSS. One thing to note here is the order is important. So if you specify the srcdoc after the owner or after the homepage, then it won't actually work. And a community member suggested the reason behind this was that since the owner and the homepage are strings, they'll fail somewhere in jQuery and that'll halt the execution. So long as we pass srcdoc first, it doesn't matter if the remaining properties fail because we only need them at the beginning of our attack to reach that vulnerable code. A popular alternative to using the array syntax, like this, was to simply declare srcdoc twice, and that would basically have the same effect. It would just create an array. So that's one approach. Another approach that we talked about earlier was using source. So it would be great if we could just set the source to be javascript::alert. And actually, it is possible to do that. You just need to make sure that you use the uppercase or the array again, and then it will trigger the alert. Another straightforward payload was the onload, so you can just change it so the onload is polluted so that when the page loads, it's just going to execute alert document.domain. And again, you need to make sure this is either in capitals or that you're using the array. One interesting payload that we got was the ontransitionend. So you can see that this actually clobbered the homepage. So we're injecting an SVG element called homepage, and then it's got a transition style, and basically we've polluted the ontransitionend to execute an alert. So it's basically going to load this SVG, it's going to start the transition, and when the transition ends, it's going to execute this. The cool thing about this is that it doesn't need capital letters or an array because this wasn't already defined, and it's extra annoying because it will continuously pop the alert. Another payload that we only received one of was this one. So onerror, you see this quite often for XSS payloads where it will try to load a page that doesn't exist, and then the onerror will trigger the alert. So in this case, it's trying to load X, so it will basically go to challenge0124.intigriti.io/X. That doesn't exist, so it's going to trigger an error, and that error is going to cause this alert to pop. Again, this doesn't need capitals because these weren't already defined. Okay, let's look at the 13 solutions that didn't pollute the owner of the homepage. How did they get around it? This one was the most common. We got, I think, 10 of these where it pollutes Q. So basically, if Q is set, it will get the real result from the server, and that satisfies the owner and the homepage checks, so you don't need to pollute these values. However, you'll still need to use the uppercase or an array trick, and notice that this one uses a slightly different syntax to do that. So just to show what that looks like, I mean, it doesn't look any different, but if you paste this into the address bar, again, making sure you consider the URL encoding, it will pop the alert, and it actually loads one of the repos. And finally, another payload that we saw polluted the base URL and set it to a domain that was owned by the attacker, and then you can pollute something like srcdoc to create the alert, and basically it's just negating the need for the owner and the repo, because the attacker domain will return that information as a JSON object. So this is just one of the examples that was taken out of the repos.json file. Finally, I just want to go through the statistics. So I broke down the payloads that we received for the 37 solutions and basically worked out that you need one element from each of these three columns. So to begin with, you can either pollute the owner and a homepage, or you can pollute the base URL to deliver those things as a JSON object, or you can clobber Q to make sure it's already selecting a valid repo. And then secondly, you need a client-side prototype pollution gadget, which you can use one of these. And then finally, you need to get around that exception in jQuery, and you can use an array, you can use uppercase, or you can pollute some property which isn't already defined. And we got some great write-ups here, so a lot of stuff I haven't covered in the video or in the official Intigriti blog post. So I recommend going and checking these out, and if you want to submit write-ups in future, we always post these on Twitter after the event and give a prize to the top 3. Anyway, this has been the unintended solutions for the January challenge. Fun fact, when Kevin released the patch version of this, somebody found the intended solution very quickly, I think like within an hour. And Johan also found an unintended solution which works on the patched version. I don't know the details about that yet, but we'll try and include a link to the write-up in the official blog post, which you can also check out in the description. And we've got some really cool challenges lined up for the next couple of months. Next month, we've got a Valentine's theme challenge, so make sure you come back for that. And I hope you've enjoyed this video. If you have any questions or comments, leave them down below. Thanks.